So now let's have a look at some of the drawing tools of AutoCAD, and we'll start it with the rectangular array command. So here we have a set of objects, which is the desk arrangement of an office chair and PC, and we want to make multiple copies of this object in such a way that it looks like the floor arrangement of an office space. For that, I will select the array tool. So go to the modify panel, select the rectangular array. Now select the complete set of objects from which you want to create the array. Now press enter, and here you'll see a default array which you may or may not want. Now in this case, you can increase number of objects in the row as well as in columns, and you can do that dynamically by using these multi-function grips. So here we have these grips. Now let's select this end grip in the horizontal direction, and I'll move it towards right, and you'll notice that number of objects will increase along with this grip. Similarly, you can increase number of objects in the column or in the height direction using the same grip. So let's now move it upwards, and here we have it. So now more objects are added here. Now, what if you want to change the gap between these rows and columns? For that, you can use these grips. So here I can click on this grip and move it closer, and the gap will decrease. Similarly, I can click on this grip and I can decrease or increase the gap. So that's a dynamic way of changing the values, but you can also do it accurately using the array creation tab. So you'll see this array creation tab as long as the command is active, and here we have some of the options, like we have number of columns, rows and levels. So let's start with number of columns, which is currently 7. So let's change this value to 8. Now press tab key. Okay, now after that we have the spacing between these columns, which is set to 2387 units. Now what if we want these objects to remain very close to each other? For that, we need to change this value. We need to decrease it actually. So I'll change it to 1500. Now press tab key again, and now they are touching each other. So that's the arrangement which I want. Now the total distance will automatically adjust depending upon the number of objects or number of columns here. Now let's move on to rows. So here we have these 4 rows. Let's change it to 3. And now we have here the gap between different rows, which is 2696 units. So let's increase it a little bit, and I'll change it to 3000 units. Press tab key, and the total distance will change accordingly, and here we have the new gap here. Now we have the levels, and levels are simply the number of objects in the z-axis which will not be visible as long as you are in this 2D space. And we have this associative option, so you can keep this option checked if you want to keep this array editable, and if you want that the array should not remain editable, then keep on this option unchecked. But now I'll keep it checked, and let's now click on close array. So here we have this complete set of objects as a single array. Now even when you click on any of these objects from this array, the complete set will be selected, and the array tab will appear with these options. Now you can again modify the values in this row and column, and you also have some of the additional options here. So using these options, you can even modify it further. For example, let's say that we want to add some extra part in this source object. So for that, we can select this edit source option, and now select the item on which you want to make the modification. So I'll select this object here, and let's click on OK. So here we have this array. Now we can modify it. So in order to modify it, I'll select the circle tool, and I'll make a small circle here. So that will act as a small gap here, which is used for the cables in the table, and I'll copy it over here as well. Okay, now this is the final geometry, and the same set of object will be visible here. So as soon as you add any modification in the source object, the change will be propagated in all the arrayed objects here everywhere. Now in order to save this, go to this last panel and click on save changes. And here we have it. The changes are saved, and now all the arrayed elements are now similar. In these cases, the gap between the array row and array column is simply the gap between any two corresponding points. So in the initial case, we have applied an array row gap of 3000 units, which is the gap between any two corresponding points. So for example, if you take this top left point as any reference point, then the distance between this top left and the second top left point will be 3000 units. Similarly, for the columns, the corresponding distance between the points will be equal to the gap which you have specified. So here we have this top left corner, so the gap between this top left corner and the top left corner of the second object will be equal to 1500 units, which we have specified. So this was all about the rectangular array tool of AutoCAD. In this video, I will tell you about the polar array tool of AutoCAD. So in the previous case, we have seen the rectangular array, and using the rectangular array, you were able to add objects in the rectangular direction, in the horizontal and vertical direction. Using the polar array, you can add objects along a circular circumference. For example, here we have this circular table and we have this chair. Let's say that we want to add multiple chairs along the circumference of this table. For that, we can use the polar array. So on the modify panel, expand the flyout, the array flyout, and select this polar array. Now you need to select the objects. So here's the object, select it, and we want to make an array from this object. So select, press enter. Now you need to specify the center point of array. So the center point of array will be the center point of this circle. And now here we have it, a default array in this case. So again, we need to change the objects, and here in this case we have these 6 objects, but we want 8 objects. So let's click here and let's now change it to 8 objects and press tab key. Now we have 8 objects here in this case. Now the angle between all of these objects is automatically calculated, and here it is 45 degrees, and also the total angle is 360 degrees. But you may or may not want this value. Let's say that we want to fill this complete set of chairs in between the 3 quadrants. We don't want any chair in this quadrant, let's say. And for that, I'll simply change this value to 270 and then press the tab key. And now here we have it. So now the chairs are arranged, all of the 8 chairs, but they are arranged in between the 270 degree angle, and we don't have any chair in this quadrant. If you want to change this value back, then simply select 360 degree angle. Now they are completely filled here. Similarly, we have the number of rows, which is 1. You can change it to 2 or 3 or whatever value you want, but obviously in this case we don't want these many rows, so I'll simply change it to 1 once again. And the level is simply the number of objects in the z-axis, which will not be visible in this case. Now if you recall the previous case, we have made an associative array in case of rectangular array, and using the associative option we were able to modify the array even after creating that. So we will again keep this option checked in this case. We will make it associative, and later on we will modify some of the objects in this array also. Now we have an option here which is rotate items. So currently the objects are completely aligned towards center, so all of these objects are simply rotating. But what if you don't want that? For that, simply click on this rotate items, and now you can see that the original object and its configuration will be retained for all of its array copies. So if you want this kind of array, you can keep this unchecked, but we don't want this, so I'll keep it checked so that the chairs are aligned towards center. And now click on close array. So now we can again modify this set of array, and for that I'll select the array and click on edit source. And once again I'll click on this object, select the array, click on OK if this message appears, and let's modify it. So I'll add a circle here, and you'll see that the same circle is added on all its copies. Now I'll save the array. And here we have it. Now even if you want to change any single object from this array, you can do that also. So I'll select the array once again, and now I'll select this replace item. And now we need a replacement item for this, so we need to first insert an object. So I'll select this block here. Now we'll learn about these blocks later on, and for now just make a mental note of this. So here we have this object. Now once again I need to go to the array, so select the array, again go to this replace item, and now select the replacement object, which is this one, and now press enter. Now you need to specify the base point of replacement object, which is somewhere in the middle here. Now we need to specify the array object which you want to replace. So let's replace this chair, so I'll select this chair and select the array, and here we have it, the replacement object is added. Now simply press enter and press enter again to exit this. You can also close this array. Now we have two objects here and we need to delete the original arrayed object. So I'll select this one, erase it, and now here we have it. So now this copy is a part of new array and it has been added as a replacement. We can now erase this object also, it's no longer required. So in this way you can replace any copy of this array from the complete set. Now in this case, if you select any single element of this array, all the objects will be selected, because while making the array we kept it as associative. Now if you want to make these objects completely separate from one another, then you need to explode the complete array, and you can explode it simply by pressing the X key on the command line and then pressing enter. So that will explode it, and you can also use the explode tool here. So that will also explode the same set of array. So both are simply same tools. You can use the command equivalent X or you can use this icon here. Now if you click on any of the object, only that object will be selected, and also this array is no longer associative and hence we cannot modify it further. But you can obviously replace objects, you can remove them, you can add extra objects if you want, for example here, but it will not remain a part of an array. So this was all about the polar array tool of AutoCAD. In this video, I will tell you about the path array tool of AutoCAD, and for explaining this, I'll use this geometry. Now here we have this simple spline, and that will simply represent the horizon of our ground, and here we have a palm tree block. Now if you want to make multiple copies of this palm tree along this path, then you can use path array, and for similar conditions also you can use the path array. So when you expand this flyout, you'll see this path array tool. Now select it and select the object, which is this one, and now press enter. Now you need to select the path, and here we have this path, so select it, and here we have it, all the objects are now added along that path. Now once again, here also we have the similar options which we have seen in the rectangular and polar array, but in this case there is a slight difference in this number of items. Now here you'll see that number of item cannot be changed, and here it is set to 14 by default, but we can change the distance between number of items. So let's now change this distance value to 4000 and press tab key. So now we are able to change the distance between items, but what if we want to change number of items? For that, simply go to the properties panel, select this measure flyout and change it to divide. And now you will see that number of items can be changed, but the gap between items cannot be changed. So you can keep any of these options active at a time. So if one of the option is active, the second one will automatically become deactivated. So in this case, we have total number of items as 10. So let's now change it to 8 and press tab key. Here we have it. Now we have number of rows which is set to 1. Obviously in this case also, if you want to add more rows you can do that. So let's type 3, press tab key, and here we have it, which is quite confusing in this case. We don't want these many rows, so that will simply make it look very unnatural. So I'll type 1 again, and here we have it. Again, the levels that can be added in the Z direction, and we have the associative option. So as long as you keep this associative option checked, you will be able to modify this array even after making it. But in this case, I'll keep it unchecked. Now again, we have the align items option, and using this align items option, you can align all of these objects according to the geometry of this curve. So here, let's say that we don't want to align these objects. We want the same orientation of this initial object or this primary object for all of our copies of this array. For that, simply click on this to uncheck, and now we have all of these objects in the same alignment as the primary object. But if you want to align them according to the geometry, then click on this align items, and here we have it. So I'll keep it aligned. That looks a little bit better. And now I'll close the array. So here we have the final array. Now if you click on any of these objects, they will be individually selected and they are no longer a part of an array because we have not selected the associative option. So if you want to keep it modifiable, if you want to modify these arrays even after making them, then ensure that associative option is checked. So I'll press escape key, and that's the final array. So this was all about the path array tool of AutoCAD. In this video, I will tell you about the divide and measure tool of AutoCAD, and using these tools you can divide the object in equal number of parts or at a particular distances. So here we have these two simple geometries. The first one is a line and this one is an spline. Now let's assume that we want to divide this line at first in equal number of parts, and we'll divide it into 6 equal segments. For that, go to this draw panel, expand it and select the divide tool. Now select the object which you want to divide, in this case the line. Now look at the command line which prompts you to specify number of segments. So we want to divide it into 6 equal segments, so type 6 and press enter. And now the object has been divided into 6 different parts and they are all equal, but we are not able to see any change. We still have a single line. Actually, the object is divided using the points, and the points are not visible in this case, so we need to change the type of points in order to see them clearly, and the point type can be changed using the p type command. So type p type, press enter, and now change it to any other visible type of point. So I'll select this cross point type. Now click on OK. And here we have it. So now you can see that 5 points are added to divide this complete segment into 6 parts. So we have the first, second, third, fourth, fifth and sixth segment here. So it is divided into 6 different parts. Similarly, if you want to divide this spline, you can select the same command. So I'll expand it, select the divide tool. Now select the object and enter number of segments. Let's add 9. Press enter. We have here 9 equal segments. So although in line we can measure the complete length of line and then we can manually calculate the distances, after which we need to add the points, but in case of a spline the same calculation will become very tedious, and for these situations this command will become very helpful. Now let's press Ctrl Z to get back to this original geometry. So now what if instead of number of divisions we want to divide this object at equal intervals? So for that we can select the second option, which is measure. Select this tool and now click on the line. Now the command line will prompt you to specify the length after which you want to add the division points. So let's assume that we want to add the points after every 40 unit on this line. So type 40 and press enter, and now here we have it. So the line is divided into as many parts as possible by creating segments of 40 unit length. So the first segment is of 40 unit, 40, 40, 40, 40, but the last segment will be of the remaining length and whatever that length might be. Now in this case, while selecting the line, I have clicked at a point which is close to this end. That's why the measurement is started from this point. Now if you want the measurement to start from this point so that the first segment over this side is of 40 length and the rest of the thing will follow in this direction and the last segment will be of any residual length, then you need to ensure that you click somewhere close to this point. To make this clear, I'll erase all of these points, and now once again I'll select the measure tool. And now I'll select this object, but this time while selecting the object I am clicking close to this endpoint. Now the measurement will start from here and enter distance as 40. Press enter, and now you can clearly see that the measurement started from this side and this segment is of any residual length. Similarly, you can use the same method for this spline. I'll expand the draw panel, select the measure tool, select this object, and this time I'm selecting a point which is close to this endpoint. So obviously the measurement will start from here. So click here and now enter the distance as 60. Press enter. And now the first distance is 60, 60, 60, but this segment will be of any remaining length. So in this way you can divide AutoCAD objects in equal number of segments or with a specific distance using the divide and measure tools. In this video, I will tell you about the multifunction grip tool of AutoCAD. So up to this point, we have made many drawings, and whenever we select any drawing or any object in AutoCAD, we were able to see these grips. So these are the different points on the geometry and which are represented by these blue dots, and they are visible on almost all of the geometries. Here also, when I select the circle, we have these different grips. And using these grips we can make multiple modifications in the geometry. For example, Here we have this rectangle which is made with a simple polyline, and I'll select it so that the grips are visible. Now go to any of these grips, the end grips, and when I hover my cursor there, you'll see these extra options which are available in the menu. Now you can use this stretch vertex. You can stretch it just like this, or you can even add a vertex. So select this add vertex and add a new vertex here just like this. Now let's say that we want to remove this one so that this vertex and this vertex joins with a single line. So again, I'll hover my cursor, select the remove vertex, and here we have it. Now if I move my cursor to this grip, I'll have even more options. So we have this stretch, the obvious one, and also we have the add vertex option, which we have already seen. But we also have a new option which is convert to arc. So let's select it, and now we can convert this object or this polyline into an arc. So this part of polyline is now converted into an arc. Now we can again go to this and we can convert it to a line again. So we have this convert to line, select it, and here we have it. Now that is not all about the multifunction grips. You can select multiple grips in a drawing using the shift key. So let's say that in this case we want to select 2 grips on the end of this rectangle. For that, I'll select this rectangle, and now we'll select both of these grips directly. So for selecting them, simply press and hold the shift key. Now click on the grip which you want to select. In this case, I've selected this. Now its color changes to red. Now click on the second grip which you want to select, and now both of these grips are selected. Now release the shift key, click on any of these grips, and you can now modify them like this. Similarly, you can also directly click on the grip and modify the geometry according to your requirement. So I'll press Ctrl Z to get back to the original geometry. Now using grips, you can also modify your geometry in many different ways. For example, on the modify panel, we have multiple tools like scale, stretch, move, and copy or rotate, and we have used these tools from modify panel. But instead of selecting them from modify panel and using them from here, you can directly use the grips and use them. Now in this case, we have this complete geometry. Let's say that we want to modify it using the grips. For that, I'll select it. Now select the grip which you want to make as a base point. So I'll select this grip as the base point and now click on it. Now as soon as you'll click on it, you'll see on the command line here, let's expand this command line to see it even more clearly, that we have an extra option here is stretch, which is enclosed in these star symbols. Now the current command which is active in this case is stretch, and you can obviously see that we can stretch the object. Now press space bar or enter, and the command will change to move, as you can see here on the command line, and now we'll be able to move the object. Now I'll once again press enter, and it changes to rotate, and the grip on which we have clicked will become the base point for rotation. Press enter again, and now we can scale it. You can enter the scale factor right now on the command line in order to change its size, and press enter again. We have the mirror tool, so now we can mirror it along this mirroring line or whatever the mirror line which you specify. Press enter again, and we are back to stretch. Now in this case, we were able to change the geometry for this rectangle only. What if you also want to change the geometry for the circle along with this? For that, you need to select the complete set of objects and now select the grip. So let's select this grip in this case, and once again we have the stretch. Press enter. We have the move tool, but in this case the complete set of object will move. We have the rotate, and complete set of object will rotate, although the change in the rotation for the circle will not be visible. Press enter. We have the scale, and now we can scale the complete set of geometry. We have the mirror tool. We can obviously mirror it. We have again the stretch, which is back to the first condition. So in this way, we can use these modify tools directly using the multifunction grips as well. And obviously we have the option of changing the geometry directly by clicking the multifunction grip also. So this was all about the multifunction grip tool of AutoCAD. In this video, I will tell you about the align command of AutoCAD, and using the align command, you can move an object and also align its geometry according to your requirement. Now in this case, we have this simple geometry here, and we have this door block. Now let's say that we want to move this door block on this part of the geometry, and we want to move it in such a way that it completely aligns with this wall or this geometry, and it also remains inside this geometry. So obviously we can do that using the move and rotate tool, and that will take a couple of steps, but you can do that directly using a single command. So expand the modify panel, select the align tool here. Now select the complete set of objects which you want to move and press enter. Now specify the first point on the source object. So here the first point is this one, this end point here. So I'll select this one. Now specify the first destination point. So we want this point to touch this point on the geometry. So now obviously that is the first point, it will move to this point. Now we need to specify the second source point. Now the second source point is this one, and we want this to touch this line. So you can select any other point on this line. So I'll select the midpoint. You don't need to be very concerned about the point here. I just simply need to click at a point on this line. So now this point will end up somewhere on this line. Now we need to select the third point, which is, let's select this one as the third point, and you need to specify third point here. So the third point will decide the direction. So we want to place it inside. So I'll click somewhere inside, and here we have it, the final geometry. Now in this case you can clearly see that the first point is here where we clicked. The second point was the midpoint, and obviously I said that by clicking the midpoint we are essentially assigning this line as the second point. So here the second point has been assigned, and the third point decided the direction, whether inside or outside. And here we have it, the object not only moved but also properly aligned according to the geometry. And using this tool you can also align similar kind of geometries on different objects. So that was the align tool of AutoCAD. In this video I will tell you about finding distance, radius, angle and coordinates from the simple AutoCAD geometries, and for that I will use this simple 2D drawing. Now here in this drawing we have the circle, arc, simple lines and also the slant line, and we will find different properties of this geometry using the inquiry commands. The inquiry commands are simply the commands which can be used to find these values, and you can find those commands here on the utilities panel. So go to this utilities panel, and here you will see this flyout. From this flyout select the distance option first. So you can also start this distance tool from the DI command. Now once the command is active, click on the first point from where you want to start distance measurement, and in this case we want to start distance measurement from this point. Now click on the end point, which is this one in this case, and we have our results over the command line. Now expand this command line, and here you'll see that the distance is 28 units. Also the angle in XY plane is 35 units. That means the angle which this inclined line is making with respect to the positive side of x-axis. So if a line is drawn here in a completely horizontal way, then the angle which this line is making with that line is 35 units. Also we have some additional values like the delta value, the delta x, y and z. So that simply means that the coordinate value of the final point when subtracted with the coordinate of the initial point will have this result. So the x coordinate of this point minus x coordinate of this point will be 22.9363 unit. Similarly, the y coordinate of this point minus y coordinate of this point will be of this value. Now to exit this command, simply press escape key. In a similar way, you can use other options of this flyout to find other values. For example, here we have the radius. Select the radius and now select an arc or circle. So here we have the circle. Let's click on it and we have the radius, and not only the radius, we also have the diameter of this circle. Similarly, you can repeat the radius tool simply by selecting the radius option from the command line here also. And now click on this arc, and the radius is 6 unit, the diameter is 12 unit for this arc. So let's now press escape key to get back to the geometry, and now we'll go to the utilities panel and select the remaining options. So the next option is angle. Now when you want to find only the angle of any line, then you can select this command. Now in this case you can select the geometry, and I'm selecting this line and select the second line or the second geometry with respect to which you want to find the angle. So I'll select this one. And now the angle in between these two geometries is 125 degrees as mentioned here. So the included angle on this side, the smaller side, will be 125 degrees. Now let's repeat it once again. So I'll select this angle. Now I'll select this line and I'll click on this line. And here in this case, the included angle here will be 145 degrees. So in this way, you can find angle between other geometries as well. Now using the inquiry commands, you can also find the coordinate values of any geometry. For example, in this case, we don't know the coordinate of the center of this circle. And if you want to find that out, simply go to the utilities panel and select this ID point option. You can also use its command equivalent, which is ID. And now click at the point for which you want to find the coordinates. So click here. And now here we have the coordinate value, the X value, the Y value, and obviously the Z value will be 0 as we are dealing with X and Y axis only in this case. So in this way, you can find distance, radius, angle, and coordinate values of any geometry using the inquiry tools. In AutoCAD 2020, this great new feature has been added, and this feature will let you measure your drawings and different properties right inside your drawing in real time. Now to see this in action, I'll go to this utilities panel, and on this panel, I'll go to this drop down right here and I'll select quick. So this is the quick measure tool, the brand new tool. I'll select this. And now we'll have this kind of cursor. So this cursor will let you measure the distances in real time. So now to do that, I'll go to this bedroom right here and look at this. Now we have two information here. We have the length, which is 12 feet, clearly mentioned here, and the width as well, which is 5 feet 3 inch from that top line to this line of the bed. But you can also move it here, just a little bit here to see this distance. So now it's 12 by 11.3. And here it's 12 by 8.9. So just by moving it, you can see the distances. Also, you'll see these icons. So these icons actually tell the 90-degree angle. So wherever you'll have the 90-degree angle, it will show that as well. Now I'll move this one to this area and look at this. Now we have the information here as well. So here we have the length and the width, and also here we have the length of external lines. So this 6 feet 1 inch, 8 feet approximately 9 inch, and the other distances are also visible. And you can also see this reference or the visual clue as to which distance is shown here. Now this tool is not only helpful for finding the length and width of these kind of rooms, but it's also helpful for finding information. For example, the radius of a circle. So right now I'll go to this one, this drawing, although this is just a direction block having little significance still. I'll just go to this and look at this. Here we have three different information. Obviously the length and width, and also we have the radius, which is approximately 1 foot mentioned right here. So it not only mentions the length and width, but also it will show you the radius values of arcs and circles wherever it's applicable. So this is the quick measure tool. Finding area from your AutoCAD drawing is one of the frequent tasks which is always done by almost everyone. And in AutoCAD, you can find area of different objects in many different ways. But in this video, I will tell you about finding areas using the inquiry tools. So here we have these two simple geometries, and now we'll find the enclosed area of this complete shape and also this one using the inquiry tool. And for that, once again, I'll go to the utilities panel, and from here I'll select the area tool. So in the previous video, we have seen these inquiry tools, and now in this video I'll tell you about this area tool. So select this area tool, and now you need to specify the area in your drawing. So here I'll select this geometry first. Now let's say that we want to find the area of this complete geometry, and for that I'll start with any point. Now click at the second point, then the third point, fourth, and the fifth. Now we have this green window, and the complete area which is enclosed in this green window can be seen directly using this command. So now let's press enter. And here we have it. So the area is 6896.7586 square units and the perimeter is 330.7268 units. So whatever the unit you are using, if you are using mm, that will be millimeter square. If you're using inches, that will be inches square. So the area will depend upon the unit which you are using. Now in this case, the geometry was quite simple. So we selected the coordinate points and we found out the area. But in this case, we cannot find the area simply by clicking because we have an arc here. Now let's ignore this circle for a moment. I'll press escape key and I'll try to find the area of this complete outer geometry. We will simply ignore this circle for now. Now once again, I'll go to utilities panel and I'll select the area. Now instead of selecting the points from this drawing, select this object option. Now click on it and simply click on the object. Now for clicking on this object, you need to ensure that this complete object is made with a single unit, a single polyline or region, and it should be connected because you cannot use this tool for finding area of this geometry. Because in this case, obviously we have these connected lines, but this line is not connected and hence we won't be able to find the area in this case. So simply click on this geometry and the complete area is selected, including the circle. Now we have the results here. So the area is 1179.5179 square units and the perimeter is here 433.9930 units. Now obviously there must be situations where we don't want to find the area of this circle. We want to exclude the area of this circle from this complete area. In those cases, you can use the subtract tool. So let's press escape key and once again I'll go to the area. And now here, look at the command line. So we have some options here like add area, subtract area. So select this subtract area first and now click on object and click on this circle. Now you'll see that the color of this circle is different, and whenever you'll find the complete area, the area of this circle will be removed from that. Now press enter. Now go to the command line and select this add area option and once again click on object and select this object. So now the final area can be seen here. So the total area was this and the area of the circle has been removed from that and the remaining area is 8828.9054 unit, which is the area of this green portion, excluding the area of this circle. Now press enter. So in this way, you can find area of different geometries using the area command or the area inquiry tool of AutoCAD. In this video, I will tell you about making isometric drawings in AutoCAD. And isometric drawings are simply 2D drawings, but they look like a 3D drawing. And generally the angle on which the axis is inclined for making an isometric drawing is 30 degrees. So in this case, we have this drawing, which is an isometric drawing, obviously. And although it looks like a 3D drawing, it's actually a 2D drawing. And we'll learn about making this same geometry here. So for making the isometric drawing, it is always advisable to keep the grid on, and you can click on the first object snap option here to make the grid on. Now this is the normal grid here, the orthographic grid, and in order to convert it into an isometric grid, or in order to convert the drawing area into an isometric drawing area, you need to select the ISO draft option. So you can select the ISO draft option and select the appropriate value, or you can simply click on this ISO draft or isometric draft mode from the status bar. So now click on it and the grid will change to any one of the isometric planes. So just right beside this ISO draft status bar option, you'll see these three planes. So we have the ISO plane right, the top and left. Now depending upon your selection, the ISO plane may look like any of these three. So we will first start with this isoplane top and make sure this isoplane top is selected. So you can change these isometric planes from this status bar option, or you can also press the F5 function key to change them, just like this. So now we are on the isoplane top. Let's start making this geometry, and for making that, I'll select the polyline tool. Now click anywhere in the drawing area to start this geometry and make sure it goes towards this direction. The 30-degree angle should be visible on the tooltip. Now enter the length, which is 50, and press enter. Now move your cursor towards this side and once again a distance of 100 unit and press enter. Now move it towards left again, type 50, press enter. Now join it with the starting point here and press enter. So now we have this closed rectangle. So let's select it. Now go to the copy tool, click on any of its vertices, move it downwards and enter a distance of 40 unit and press enter. Now press enter again to exit the command. Now I'll select the line tool and I'll join all of these vertices. So join these vertices, press enter and repeat it. Go to these vertices, join them and join these vertices. Okay, so now we have these geometries. Now we will make this part of this isometric drawing, and for that I'll once again select the line tool and I'll click on the midpoint of this line. Now move it towards this direction and enter a distance of 30 unit and press enter. Now move it towards this side and click at this intersection point. Now move it downwards and enter a distance of 20 unit, press enter, then move it towards left and join it with this point. Okay, so here we have these geometries. Now we need to clean this drawing. In this video, I will tell you about the center line and center mark tool of AutoCAD, and these are quite new tools which are added in AutoCAD 2017 version. So now here we have a circle we have a set of parallel lines and a set of intersecting lines. We will start with this circle. Now you can find the center line and center mark tools on the annotate tab. So go to this annotate tab, and here you'll see these tools, the center mark and center line, on the center lines panel. Now click on this center mark and select a circle or an arc. So in this case we have a circle, so click on the circle and the center mark will be added directly. Now press enter to exit this command. Now the default center mark has been added, but you can still modify its settings. So select the center mark and you'll see these grips. Now using these grips you can change the length of this center mark along all of its 4 sides here, just like this. And when the radius of this geometry changes, the center mark will automatically change its size, just like this. Now in a similar way you can add a center line also. So here we have these 2 parallel lines. Now in order to add the center line, simply select the center line tool, click on the first line, the second line, and the center line has been added. And here also the center line will remain connected to its parent lines. So select any of the parent line and change its angle. But when you change its angle, the center line will also change accordingly. In a similar way, if you add a center line here on the intersecting line, then it will be added at the angle bisector. Now this will directly bisect the angle which this line is making here. And in this case also, if you change the angle of this line, or even if you change the gap between these 2 lines, the center line will change appropriately, just like this. Now in this case too, if you want to change the length of these lines, you can easily change it by using these grips. You can modify it just like this. And we also have one more command, which is ch property command, which can be used for changing the property of these objects. So type ch prop and press enter. Now select the center mark or center line whose property you want to change. So in this case I'll select the center mark and now press enter. So we have a set of properties here that can be changed, and you can use this ch prop command on other geometries also, and we'll learn about this command later on in the next module also. So for now we will only change one of the property, which is line type scale. So here we have this line type scale. Let's select it and let's change this line type scale to 2. The current value is set to 1. Now press enter and press enter again. And you'll notice that the scale of this line now changes and it will now increase. You can compare its scale with these lines here. So you can change some of the properties related to this center mark, center line directly using the ch property command. If required, you can also change the properties of these center lines and center mark using the property palette. And the property palettes can be seen by selecting the objects and selecting the property option from the contextual menu. Here we have this property palette. So we'll learn about this property palette also later on in the next module. So you can modify its properties from here as well. So this was all about the center mark and center line tool of AutoCAD. So up to this point, we have seen many simple 2D geometries in AutoCAD, for example, line, polyline, arc, circles, and ellipses. There is also a different kind of geometry in AutoCAD which is called region. And you can make region using the completely closed geometries. So let's make simple geometries here. I'll make a geometry with this circle tool and another one with this rectangle. Also, I'll make a geometry using this line command here. Now in this case, if you select these geometries, you'll see the normal grips, and also the behavior of this object will be of a polyline because it's made up of a polyline. Now if you select the circle, here also we have the simple grips. You can modify these objects like this using these grips, and its behavior will be very much similar to that of a circle. In this case, obviously we have these separate lines. You can select them and their behavior will be something like that of a line. Now once we convert these objects into region, their behavior will completely change. And in order to convert it into region, you can use its command equivalent region, that's region, or you can go to this draw panel, expand it and select the region tool. Now I'll select this region tool and now click on this circle and press enter. So now this object has been converted into a region, although we still have the circle just right behind this, but we now have a new object also here. Now here in this case we have a simple polyline. Let's convert this one into also a region. So I'll select the region, I'll click on this and press enter. We again have a new region here. Now I'll convert this object into a region. In this case you can see that we can select it separately. Let's now go to region tool and select all of these objects and press enter. Now when I move my cursor, you can see that we have a region here as seen on the tooltip, and the complete geometry will be selected. So in all of these three cases we had completely closed geometry. That's why I was able to convert them into region, and that's one of the conditions which needs to be fulfilled for converting an object into a region. Okay, so now we have the regions. Let's look at the difference here. So I'll select this object and obviously I select the region and I'll simply move it from this point. So I'll select the grip and move it here. Now that's the region, and this is simple line geometry which we initially had. Now in this case the object will behave as a rigid geometry. As you can see that I can move it directly using my grips. Even in this case I have this region, and if I move it I can simply move it using my grips. It's completely rigid shape. But in this case the original rectangle, if you move it with these grips, it will deform, it will stretch and it will behave accordingly. So that's one of the differences. Now another difference between a region and a common geometry is the ability to perform Boolean operations. So I'll explain it in a moment. For that I'll just clean this drawing area. So I have this region. Also I'll select this circle and I'll separate this region. Now I'll remove all of these geometries. They are no longer required. Now we have this circle which is a region, and also this rectangle which is a region. Now I'll move them one over another in this overlapping position, just like this. And let's make 3 copies. So go to copy tool and the second copy and third copy. Now all of these objects are made with region. Now let's select the union tool, the first Boolean operation. So I'll type union and press enter. Now you need to select the first object and the second object and press enter. And look at the geometry now. So both of these geometries now combined, and they combine to form a single region like this, which is a completely rigid shape, just like this. Okay, now let's type subtract and press enter. So that's the second Boolean operation. Now for subtract, you need to first select the object which you want to retain. In this case, we want to retain this object. Press enter. Now click on the object which you want to subtract. Now in this case, when I select the rectangle, this portion, the common portion of rectangle and circle, will be subtracted. And also this remaining part of the rectangle will be erased. So let's select it, press enter, and here we have it. Now this part has been removed and also the remaining object has been removed, because we selected the circle initially. Now let's reverse the process. I'll press Ctrl Z and I'll type subtract again. And now in this case, I'll select this rectangle first. Now press enter, select the circle, and you obviously know what will happen this time. Here we have it. The circle will be removed from this rectangle or this rectangular region. Now in this case, I'll use the third Boolean operation, which is intersect. So let's type intersect. Now in this case, only the common portion of intersecting geometries will be retained. So I'll select the first object, the second one, both of them are regions, press enter, and we only have the common region from both of these geometries. So in this way, we can use the Boolean operations on the region objects. And that's all about the region tool. Okay, so now this model is complete. Let's make this drawing using all the tools which we have learned so far. And for making this, we are going to use the array tool. To be specific, we'll use the circular array which we have learned here. So I'll start with the circle command. So I'll go to draw panel, select the flyout and select the center radius circle. Now click at any point in the drawing area to start it and enter a radius of 2 unit and press enter. Now press enter again to repeat this command and go to the same center, and this time enter a radius of 5 unit and press enter. So there we have it, 2 concentric circles. Now we need to go to the circle tool again, click on this quadrant, and now again make another circle with radius of 0.8 unit and press enter. Now we need to trim this part. So I'll go to trim tool, press enter and remove this portion. Now we need to make the array. So go to the flyout here and select polar array. Now click on this part, press enter, and now click on the center, which is here. So in this drawing we have 11 instances, and in total we need to make 12 instances because one of that is removed and the groove has been made instead of that. So I'll select here 12 as number of items and press enter. So here we have it. Now make sure associative is unchecked and then click on close array. Now we need to clean this geometry. So I'll go to trim, press enter and remove these portions. They are no longer required in this geometry. Okay, so now we need to make the final groove here. So I'll simply erase this portion. It is no longer required here. And here we have already trimmed this portion, which we should not have trimmed. So in order to extend it, you can go to the modify panel and here select the extend tool and press enter. Now click on this portion and there we have it. It is now extended back. Okay, so now I'll go to the line tool, click on the center and make a straight line. It should be long enough to pass this circle completely. Now go to offset and enter an offset distance of 0.5 and press enter. Now click on this line and click upwards, then click on this line and click downwards and press enter. Now go to trim tool, press enter and remove this complete portion and this complete portion. Also zoom into this area, remove this part and remove this part. Now remove this line, it's no longer required. There we have it, the final geometry as per the dimensions mentioned here.